Video. And the Hangout is on the air. We're live. That's exciting. Hey everyone, we're going to get started in just one more minute. We're going to give people a chance to jump on. So hang in there if you're live and watching. I'll sit here with you and wait for the event to start, and in just a minute I'll get started and talk about what we're doing today. I feel like this is the moment where I should start using like the Google like impose the hat or impose the extra beard on the beard look or something like that, just to entertain our viewers at home. All right, well, we're going to get started. Welcome everyone. My name is Seth Proctor. I'm the CTO here at NuoDB. Thank you for joining me for another NuoDB Unplugged series. It's late July here in Boston. That means it's getting wicked hot. People are on vacation. Things are kind of moving at a different pace, and so we thought we'd do something a little bit different today. We've had a number of requests for demos generally of the product, and about a month ago I was down in New York at the Cloud Expo at the Javits Center. And I gave a demo to about 120 people there, and I had a lot of people say that they really enjoyed it. They told their colleagues about it, and their colleagues wanted to see a reprise. They wanted to see it done again. So for those of you who are in that group and watching at home, this one's for you. What I'm going to do today is I'm going to show a demonstration of essentially the management capabilities of our software. And I'm going to talk about what it means to run our database in multiple locations and kind of what the implications are of an architecture that gives you deployment flexibility so that you have choice of physical locations, you have choice of your technology stacks, which clouds do you want to run in, and kind of illustrate why it's useful to be able to run in a hybrid deployment, run across different environments. For those of you who are unfamiliar with NuoDB, the short version is that NuoDB is a distributed web scale database. We're a SQL database. We're a fully ACID, fully transactional system, but we're designed around a fundamentally new architecture, what we call a durable distributed cache. And essentially that means that we think about the system in two tiers. We think about it as an in-memory tier, where clients connect, where transactions actually are run, where we enforce the rules of atomicity, consistency, and isolation. We maintain on-demand caches, so we run at in-memory speeds, but we run very efficiently with locality to where clients are connected. And then we have a second tier which thinks about data durability. That's the D in ACID. I feel like I should have had that like written out on the whiteboard next to me. So just imagine if you've seen like our videos where we superimpose things on whiteboards magically. I would put my hands here, and our marketing team magically later will figure out how to make things just like pop up behind my head. So just imagine that's happening. So basically, our system works in this two-tier approach, and then there's a third tier on top of it that provides management capabilities, that provides cloud provisioning, that provides a security model, that provides monitoring, and that lets us build some pretty interesting tools and management capabilities on top of what is essentially a distributed system. And it also means that we can scale the system separately at these two tiers. We can think about data durability as a separate concern from how we do transactional processing. And that provides a number of really nice capabilities. And it gives us a great deal of flexibility in terms of how we scale. It gives us a great deal of flexibility in terms of where the database is run. And it gives you separation in terms of how you operationally manage the database from your application logic. And I think that's one of the really important features here, is that what I'm going to show you today is something that is demonstrating operational flexibility, but doesn't require your application to change. The things I'm doing today are against a live database that from an applications point of view is always available and always looks like a single logical database, even though it's running in different locations. And so what I'm going to do right now is I'm just going to pull out the screen sharing capabilities of this chat. Let's see. Good. And can we, that looks live. Good. Okay. So what everyone at home is looking at right now is our new web console that we've been working on and to make the standard interface that you can work with when you start building databases on top of NuoDB. It's a very simple, streamlined web interface that's actually built on top of REST management interfaces. And so everything you're seeing here is available through this GUI. It's also available through command line tools. You can get all the same functionality through Python scripting or through direct REST calls. And so this is all designed to be something simple to work with out of the box, but it also plugs in very nicely and simply to any kind of monitoring or management framework you have today. And before I go any further, I just want to say that the Google chat has a place in it where you can enter questions, you can make comments, and so as I'm going along, I'll try to periodically kind of watch that and make sure that there are no questions popping up as we're doing this demo, but please feel free to ask questions, and either I'll get to them while I'm doing the demo, or we'll get to them at the end of the session. So looking at the screen here, you can see a couple of things, but first of all, you can kind of see our approach to working with a distributed system. So before this session started, I went on to Amazon, to AWS, and I deployed a number of instances, and that's what you see right here. You see I'm sitting here in front of a single web interface, and from one place I can monitor things like the memory being used on each of my systems. And so I can see that memory utilization is pretty low and pretty even across all of my hosts. So I have an idea that kind of I'm reasonably well provisioned to start doing some database work. I also can see that there's a fairly small amount of CPU utilization. That's what I'm looking at right here. I can see one of these hosts has a little bit more work going on than the others, and that's because that's the host where I'm running this web console and where I'm also doing some statistical collection. But you can see on average we're still pretty low. And for those of you who are curious, all the hosts I'm running on this demo are with the baseline R3 instance, which is a memory optimized instance. So one of the things that we've been building out in NuoDB is a feature that we call templates. And templates are basically they're a service level agreement. They're a simple declarative language for describing a problem you want to solve. And this is important in a distributed system because distributed systems are complicated, they're hard. And when you use NuoDB, what you want is you want to be able to use the database. You don't want to worry about how to manage a system. And so what I can do through this new interface is I can go in and I can say, I want to create a database. All right? And I'm going to create a database. I'm going to call it demo. I'm going to pick a DBA username and password, and then I'm going to pick that template we were talking about. I'm going to start out as if I was just a developer and I kind of wanted to play around. I wanted to kick the tires, right? Or just start some basic testing. Maybe this is like a dev test environment. Maybe this is a simple get up and running on a small database. You're a self-service shop. Maybe you're trying to provide some kind of service model, and so you tend to start databases in the smallest mode possible. And so I'm going to tell the system to start a single host database. So it's going to go off and it's going to think about that. And now we can go into our web console here, and we can say we have this little demo database running. And we can see that it's running on a single host, and it's made up of two processes. It's made up of what we call a transaction engine and a storage manager. You can see that if you click through here. And all that means is essentially that transaction engine is that in-memory process I was talking about earlier. It's where clients actually connect to the system and we do transactional work. And that storage manager is running providing data durability. And so between those two processes, we've got a fully ACID database running. And we can see that there's a little bit more activity going on, but not a lot, because the database at rest is not doing a whole lot of activity. Okay, so that's great. I've got a database running. It was pretty simple to get up and running. And I can continue to watch basic statistics here. And if I wanted to start to expand what I was watching, there's a number of kind of baseline statistics that are useful. And then through our APIs, there are about 80 or 90 other statistics that you can watch in various aggregations, various correlations to keep track of what's happening across the system. But now let's say that time has passed and you've been testing against this database, and now you want to start growing into something that looks a little bit more like a real deployment model. And so what I can do through this template mechanism is I can go into my demo database, and I can say against that running database, I now want it to run in what we call a minimally redundant model. I want it to run in a mode where there's redundancy at that transactional tier, and there's redundancy at the storage tier. So any host in the system can fail, and the database is still completely available. So all I have to do is go in and say, change the configuration, and our system is going to go off and look at things for a few seconds, and then it's going to reconfigure the database. And so you can see now we've got that same live database running, but now it's running on 3 Amazon instances. And it's made up of 4 processes, 2 of those transaction processes and 2 of those storage points. While this was happening, the database was still fully available. So the application kept running. The only thing that's changed is that the application now has 2 hosts it can take advantage of instead of just the 1 host. So now you can get additional throughput, you have higher availability, but it was very simple, as you saw, to do. And I'm still just managing it through this 1 point. So that's pretty cool. I think that's pretty unusual for a database to be able to just expand like that as you need it. So now let's say you're continuing to do evolution against a NuoDB database, and right now I've been running on Amazon all in the East Coast data center. I've been running in the Virginia data center. Now we can see that. We click through, we can see these IP addresses. We can see we're in region US East 1, and that's Virginia. And that's great, but now maybe I have clients on the West Coast who are starting to come online. And what I really want is I want my database to expand to run in multiple regions. That's higher availability, but then that also gives my users on the West Coast good low latency experience of the database. And so I can do the same thing. Again, I can go in and I can say edit the database, but this time I can tell it to run against a geo-distributed template. I can tell it to expand to run on resources across multiple regions. And so I submit that. I let our system think about that for a few seconds while it figures out kind of what the right configuration is, where the resources are that are available, brings new peers online, gets them talking to each other, and there we go. We now have that same database. This is live in Amazon, right? We have that same database running, but now it's running on 12 hosts. And it's running in 3 Amazon regions. In this case, that's US East 1, which is Virginia, US West 1, which is California, and US West 2, which is up in Oregon. And so we've got a single logical database. Again, the application logic didn't change. The applications just continue to run against this database. But now it's spread across these 3 regions. And so if I have application logic that's deployed in the California data center, or deployed in the Oregon data center, those applications will be talking to the local transactional peers. So they'll be getting local, low latency access to the database, even though it's a globally consistent, transactionally consistent system. And so that's pretty neat. We now have a database that's running East Coast and West Coast. It's highly resilient. But when I do this demo, I always feel a little bit bad because I feel like I'm giving short shrift to everyone who's somewhere in the middle of the country. It turns out in the United States we sometimes have a bias towards things on the East Coast and things on the West Coast, but it's a big country and there's lots of people in between, and they may be interested in getting that same kind of low latency access to the system. And the challenge here is that Amazon it's a great environment. It's a great place to be able to get up and running and do these kinds of tests and deploy your logic, but it doesn't have a data center in the middle of the country. There's nothing I can offer. right? And that's a challenge. And so something I can do is, I'm doing off camera, you can't see this at the moment, but what I'm doing is I'm bringing online, just reload this, there we go. I'm bringing online a fourth region. I'm bringing online US Central. Now, there is no Amazon US Central, right? So what I actually just did was I went into an account I have on the IBM SoftLayer cloud, which is a totally different stack. It's a totally different environment. But it's also just a public cloud. And so I installed NuoDB on Linux instances there. Different hardware, it's a different set of operating systems, different disk systems, whatever else, but that doesn't matter because NuoDB is a piece of software that can run in a heterogeneous deployment. It doesn't care that you're running in mixed mode networks, mixed mode hardware, mixed mode disks, mixed mode operating systems. All it needs are peers that are online and can talk with each other. And so I brought up, as you can see here on the screen, I brought up 2 additional hosts. And I just called it US Central. But what I really did was I brought up 2 hosts that are in the Austin data center in SoftLayer. And so now I've got, in addition to the original 12 hosts that I had in Amazon, I've added 2 hosts in SoftLayer. And now if we go back to our demo database here, we can see, because I'm running it against one of these templates, the database is automatically expanded. It's now running in 4 regions. It's now running across 14 hosts. And again, the application logic didn't change, but now I've got something in the center of the country, right? And now I have some really interesting questions I can ask. You know, did I do this because I wanted to bring my logic into the data center in Austin so that users in the center of the country could get lower latency access to the system? Maybe I did this because what I really want to do is I want to start testing a new cloud environment and see if that's a more interesting place to work. Maybe what I really want is I want resiliency and independence, so that if tomorrow I discover I'm having a problem scaling in one cloud, I can move to another. Or maybe I'm providing a service, and I have some users who really want to deploy in SoftLayer and some users who really want to deploy in Amazon, but I'd like a single place to be able to manage all of my resources. Because again, from this single point, I can watch all these statistics, and not just statistics about things like, you know, individual host memory or CPU, but right here I've got a breakdown by region of network traffic, right? So this is letting me monitor across those different regions how things are communicating with each other. And so when people kind of ask me why you're interested in these kinds of hybrid deployments, I think the answer is because you know, sometimes it's out of necessity. You're running in your local data center, and what you really want to do is you want to bring a cloud online somewhere to expand your resources. Sometimes it's about independence. You want to be able to test and develop and deploy on multiple clouds because you have users in different environments, because you want to physically get closer to a different set of users, and one cloud doesn't provide all those options. Sometimes it's about resiliency. You're worried about one cloud going down, or one cloud not providing all the kinds of capabilities and resources you want. But I think fundamentally, what's really important is that what I've really just demonstrated, I'm going to see if I can, there we go, stop screen sharing and come back and talk to everyone for a second. I think one of the important points here is what we've done at NuoDB is we've provided an architecture that really is independent in terms of the resources you're using, in terms of the clouds where you're deploying. And so you have these kinds of options, right? And so this really means that when you're choosing a cloud to deploy in, you're not locking yourself in, right? We have the same philosophy that our schema is flexible, so that as you develop your application and your schema needs change, you can change your schema online. It's constant time. You don't have to take down the database. You don't affect application performance. You can just evolve your application. You should be able to do the same thing operationally. In the cloud world, in the modern scale-out world, you should have the flexibility to be able to decide tomorrow that you want to go to a new cloud, or you want to change your hardware or your operating system, that you want to be able to expand to take advantage of resources when Google suddenly drops their prices 50%, or Amazon provides some really exciting new feature that you want to take advantage of, or you're working on some new account and someone comes along and says, SoftLayer is where I want to be, or Azure is where I want to be, or Rackspace is where I really want to deploy. And you shouldn't be tied down to one of those environments because you have a database that needs to be on a LAN or needs to be in some kind of very tight deployment model. And so that's really kind of what I think is cool about this. Is it's pretty interesting to be able to run in multiple places, but more importantly, as a developer, as a technologist, when I look at this technology, it gives me the flexibility to know that tomorrow if someone comes to me and wants to run something in a whole new environment, I can do that. And it just gives me a lot of great flexibility, and it gives me the ability to play with different architectures and try out new ideas. So hopefully that was an interesting introduction. I'm going to hope that some folks ask questions. We have one question here. And the question is whether we have a driver for Ruby. And yes, we do. If you go to our GitHub site, so that's github.com/NuoDB, you'll find we have a number of community drivers. One of them is for Ruby. We have Ruby support. We also have active record support. So for those of you who are doing development on Rails, you can get up and running. We also, for folks who are interested, we have a Python driver, and we have an integration with Django. We have PHP PDO support. And so in addition to kind of all of the traditional enterprise languages for Java, JDBC, and Hibernate, for .NET and Link and Entity, for C and C++ and ODBC developers, we have all of those drivers, but we also have a number of the kind of newer languages and development environments that play well in these kind of cloud deployments. Let's see. We have another question here. The question is from Jim, who's asking, can I talk a little bit about how you might allow future partial data subsets in a geo-distributed environment? Yeah, Jim, that's a great question. So part of what I showed in this demo was a feature that I commonly hear people ask for, which is the ability for data replication. So in this demo, as I was expanding out, I was bringing new data centers online, I was bringing different clouds online, and I was automatically setting up data replication. And so whenever I'm making a change to the system, that information is being replicated to all of those regions. So that gives you data resiliency, it gives you redundancy. It means if any one of those regions failed or any one of those clouds failed entirely, you still have access to your data. And that's obviously a great feature. But that's only one use case that people really care about in this kind of hybrid model. An equally important feature to people is the ability to specify that certain data does not need to be replicated between clouds. And there are a couple reasons for that. One, just going back again to our demo that we've got running, one of them is pretty obvious. It's this picture right here, right? It's that in a distributed system, there's communication going on between all the nodes. And one of the things that we're really passionate about here at NuoDB that we put a lot of effort into is to building an architecture for a number of reasons that minimizes the amount of communication. And if you're interested in that, I highly recommend you check out our tech blog, our white paper, some of the other material we have online. But no matter how much you minimize coordination, you still have information going between peers. And as you start replicating all data between all regions, that can become expensive. And more importantly, there may be legal reasons, there may be audit reasons, there may be any number of good reasons for wanting to keep data local to a given region. For instance, if I spun up some new instances somewhere in Europe to support European customers, they'd probably love to be able to get in on this database. But if you're talking to a citizen, for example, of Germany, their personally identifiable information, their PII, needs to stay on disk in Germany. That's a very important requirement. And so one of the features, Jim, that we're working on right now is around being able to partition at the storage layer, be able to partition where data is stored. And so the application still sees what looks like a single logical database. Data is still available everywhere. data is still transactionally consistent everywhere, but you have some control over what data is replicated to all locations and what data can be kept local, either for kind of efficiency and manageability reasons, or even for kind of legal and audit reasons, something called data residency. And for folks who are interested in that topic, you should stay tuned to this website, because that's a topic that we're working on pretty actively right now that I personally think is pretty exciting. And we're going to be talking a lot about that in the coming months. So if you're interested in that, if you'd like to learn more, definitely get in touch with us. I'd love to hear your use cases. I'd love to know more about kind of what you're thinking in those spaces. But yeah, definitely a great question, Jim, and something we're actively working on right now. So we're coming up on the end of our time here together. I hope you've enjoyed this demonstration. I just want to say, in terms of the demo I gave today, I was tempted to use kind of a bleeding edge development build and show you some of the cool new features that we've got going on in the product. But what I actually demoed today is what's available now. So you can go to our website. You can download the latest build, which is 2.0.4, and in the product, you have to run a script to kind of enable some of these new features. But in the product is everything I showed you today. So you can go download the product. You can try putting it up on Amazon. You can try putting it on your local system, and you can get access to the web console that I was using. You can start looking at those statistics. You can start playing around with the REST interfaces. Again, you can go to our GitHub site if you'd like to download the Python APIs that we have to work with it. That's a pretty nice way to actually work with the management tier of the system. And as always, if you've got questions, if you'd like to see more of what we're doing, if you'd like to understand more of the technology behind what you saw today, or if you have ideas for future events, please go ahead and send them in. The email address is available with the Google group. You can find us on Google. You can find us on Facebook. You can find us on Twitter. My name is Seth Proctor, and I've had a lot of fun doing this demo. I hope you've enjoyed seeing some of the tangible examples of what it means to run hybrid across multiple clouds, and I hope this is getting kind of your gears turning about some of the exciting things you can do when you have real flexibility, when you have the ability to decide where you're going to run. And so until next time, please go check out NuoDB, and I hope everyone's having a great summer. Talk to you all soon. Bye.